This is ITEC 4242 Database Administration. Welcome to week 3. I'm your professor Aaron Hill, and today we will be exploring chapters 2, chapters 5 in the textbook, as well as module 2. Now, before you get all upset and say, hey, that's 80 pages that we have to read in the textbook, fortunately, it's not all of chapter 5. And I'll get there when I get to there in the slides, but basically it's going to be half that at best. So, as I flip to the correct part of the textbook, instead of chapter 5, we're going to be reviewing chapter 2 and defining an organization's DBMS strategy. So, a company may have multiple DBMSs and applications that are tied to them. Why? Well, there's various reasons. One may be some became a little bit more deprecated over time, but data is a commodity. You can't just get rid of it. Some companies may have retention policies, but otherwise, you may have to keep track of certain databases and versions and the like. Let's use us as an example, Middle Georgia State University, going through consolidation, and you're going to hear a lot about consolidation during the slideshow presentation. So, inside look into the database administrator side of things concerning Banner. Okay, so we are on we're on Oracle 11.204 for our production Banner system. However, unbeknownst to many other than staff and faculty, we still retain the Macon State and Middle Georgia College Banner systems. Why? Because we have to make sure that we have the records on file, and our production system only goes back so far in time. We only retain so much in the production system, and if we have a returning student from X amount of time that exceeds our current system, we can go back and look at the old systems. It's all about verification and again, part of retention policies and all, we have to keep them for a certain period of time. Well, they're not on the same version. So we have multiple Oracle DBMS programs running off of our server. Now that's only one product. There could be any number of products from SQL Server, DB2, heck, throw in Microsoft Access while we're at it. It all really depends on scope and necessity of departmental or school-wide needs. And we'll get to I'll expand more on that as the chapter goes along. But in choosing a database management software system, whatever, you have to make sure that you have the right operating system support. You've got to have a DBMS that supports the type of organization you are. If you need a tier 1 grade A product, you might need to invest your time in Oracle or SQL Server. Whereas if you're a smaller business, smaller databases such as MySQL may actually function appropriately for you. Benchmarks and tools. You need to have a database system that is going to keep up with your transactions. If you have hundreds of users consecutively trying to run transactions, you need a database system that's going to support that. Whereas a homegrown business that may handle 2 or 3 people at the same time at best, you can afford to cut costs and have something a little bit smaller. as far as supporting tools, what kind of vendor and third-party software do you use? As far as we're concerned, not only do I deal with Banner, I deal with our ticketing system, Bosscars, I deal with Nelnet, and I deal with probably any number of other third-party software. And some of our programmers are in charge of things such as StarRes, which handles housing, dorms, and all that other assignments and all. And all of these have to synergize and work with the software that you have currently. If you're going to upgrade or you're going to buy new software, you have to verify that all of these components that are third-party software or even local modifications that you've made function appropriately. You also have to have experienced technicians. You need staff on hand that know what they're doing. So that's going to take training on the part of the people that you have if they're not experienced with it, which generates cost. And there might be a release schedule that is unrealistic for your company to keep up with. You may want something that updates semi-regularly, or you might be a type 1 company, as we'll discuss with the chapter 5 content, that you need to keep up. You need to be a tech leader. You need to be at the head of the game. All really depends on the environment of the company that you work in. There are also reference materials, white pages, support documents, other professionals that you can get in contact with. How much out there is there about the given software, the given DBMS that you work with? How much is out there to support the things that you want to do? Because if there's not a lot of support, if there's not a lot of stuff out there for you to support your particular DBMS, you might be in a world of trouble, and you might have to be one of the front runners to make these documents. Let's see. As far as DBMSs are concerned, they vary in size. Enterprise level is the type that we typically think of as far as like Banner. It's used by Middle Georgia State University and other parts of the university system of Georgia statewide. And you want to be able to have a robust working database management system that runs alongside that. As far as departmental, you may want a database that is simply going to work in your department. It really doesn't matter to the rest of the company. The rest of the company may not even care. A good example of this to kind of give you perspective. Well, it's not quite right, but for the purposes of this example, let's say the bursar's office deals with payment software. They deal with payments and all financial stuff outside of the financial aid aspect. And they need something custom built just for them. Okay, well then, quite frankly, they'll need that. Another departmental one that we had was with distance learning last semester. Professor Steins and I actually helped to design a database for learning support concerning a program that I forget right off, but that's limited in scope to a particular department. It has nothing to do with the School of IT, it has nothing to do with the School of Nursing. It's very limited scope. Now there are personal databases, and this is actually how I got started This is what hooked me as a database administrator, because I created an MS Access database while in school, working full time. I worked for an airline that I had to work as a records analyst and audit engine records. And I created an Access database that was basically a glorified calculator, if you will. But it kept track of my audits, and if there were any sort of discrepancies that somebody else would find, against their own audits, I could pull up my audit later on and say, oh, well, that's because of this, or perhaps it was a typo on my part. But it was easily accessible and something that I could refer back to cover my own butt if something went wrong. And this actually helped out third-party vendors that we had that worked with engine components, as it saved them a lot of time because they needed to go back and review the work of the auditors. And for me, I was able to basically print out my work that basically explained from start to finish what I did and why I did it. And this saved them several days' work in a lot of cases, and sent them home happy and way ahead of schedule back to their loved ones and their companies, and they were able to actually get ahead of the schedule and get work done that they really needed to. There are also mobile and remote devices that you may have a database on your phone that syncs in with perhaps an enterprise level database that they enter information into that database on their phone, and it allows them to keep track of records and all, and when they get back to work or whatever, it'll sync up the data that they may have dealt with. This might be useful for, say, recruiters that are on the go, they're mobile, and they don't necessarily take their whole office with them. They may meet students or other people on the fly, and they can store the information mobily and be able to sync that up with a system. Not saying that we do that, but that's kind of an example that would be possible. Okay, continuing on with this, there's clustering, which may improve the database performance by utilizing enhanced availability and scalability techniques. Clustering can be performed on the database level or the server level. I don't particularly have a lot of clustering experience, but that's something that's on the horizon that I would love to pursue in greater detail. There's proliferation, where if let's say one of the departments, we'll throw financial aid under the bus on this one. I love you, financial aid. But with the financial aid department, let's say that they decided that they needed their own DBMS system, good, bad, or indifferent, and they went ahead and bought it without consulting the Office of Technology Resources, which is our basically IT department. But if you say IT department, people get confused with the School of IT. So we're the Office of Technology Resources. Let's say that financial aid decided that they wanted their own software, and they decided, without consulting anybody from tech support, Office of Technology Resources, they get it, and then they want people to support it. They want our department to support it and provide server space and resources dedicated to it. Well, considering they bought it, we might very well acquiesce to this, or we may not have the manpower to support another system. It all really kind of depends. That's why you have strategies in place. It's why you have standards and practices so that departments such as the bursar's office, financial aid, admissions, academic affairs, any of those, that there are meetings, there's strategy involved to get everybody on board to basically create a mind trust and to understand what we're capable of doing, who can support these systems, and how we're going to implement them should we pursue them. There's hardware. How do we manage the hardware strategy wise? We got to have room for growth for a database management system and multiple databases that a a college in this case, a university in this case, or a, a business may need to support. And there is the idea of the cloud, having somebody else, having a third party basically handle your technology needs for a database. You may be relinquishing a certain level of control and security, and that may not be on the agenda for a company. That might not be ideal, but for some companies that don't want a bigger IT budget, that might be a valid strategy. Okay, installation. Something that I am very fond of and very familiar with by this point. Uh, the first thing that you really need to do when you're installing a product or actually upgrade, because a lot of this is going to fall under the same umbrella of upgrades. You're going to have to look at prerequisites. You're going to have to look at support documents that vendors such as Oracle or Illusion, in the case of Banner, provide to ensure that whatever your upgrades, whatever installation that you need, that you have all the right systems, whether minimums or uh, growth will require over time. Uh, you need to have some sort of guide and vendor to be able to fall back to be able to uh, talk to should there be complications that arise, or perhaps they can clarify unclear terminology or concepts that are within their documents. As far as hardware memory requirements, I feel that this is almost redundant in a sense because these should be within a prerequisites, kind of. But sometimes you actually do find them outside of the prerequisite value. And of course, when it comes to hardware and memory space, you need to take into consideration growth, expansion, because as as you get more students or you get more customers or you get basically more records in general, you're going to get more and more data. And depending on your retention policy, you may not be getting rid of these records in any time soon. So you really need to take into consideration what that level of growth is over the amount of years and what you'll need. As far as storage requirements, this one's a little bit interesting, especially in the case of Oracle. I feel that this is a little bit different. As far as storage requirements are concerned, when it comes to Oracle, and I realize we're using MySQL, but I'm more familiar with Oracle and how it handles and stores documentation, whether it's log files or backup files or whatever. It typically uses what are called initialization parameters, and it has parameter files that either static or dynamic that you can define where content is stored. Now, if you're if you have partitioning, this is especially imperative to take into consideration, because partitions are, those not familiar with partitioning, is you have a file structure where, kind of like Windows, where you have C drive, D drive, various different hard drives and space, basically space components that you can store software, but there's a limitation to that. And this can be a showstopper if you run out of space in a particular partition. Or if you're not partitioned, then you need to be able to understand where you're storing files. And if you have parameters that point at directories and folders that don't exist, you might run into errors. So you need to consider not only the space allocation when it comes to storage requirements, but it's also defining actually existing locations to make sure that everything runs without a hitch. Configuration, as far as installation goes, that kind of falls under the same thing that I just kind of said about initialization parameters, and trying to make sure that everything's configured to your environment in the right way, where you don't have errors, that you're not over allocating resources, that you're not trying to put things where they shouldn't belong. And testing. This is always a big thing, and sometimes it can be one of your most problematic resources, because in order to test, you have to have people that know what they're doing testing. Let's say in my example, when it comes to Banner, I do a lot of support on the back end, and if somebody runs into errors, I may look in support documents to try to find and troubleshoot the cause of an issue. However, I don't really deal with the front end system as much. I don't know how to do financial aid. I'm not a pro at financial aid. I salute them that do that for a living, but I don't know their job, and they're probably thinking goodness and all that they don't have to deal with my stuff either. So testing, you got to get the enough volunteers or recruits from other departments that work with different varying processes to basically come on board and test, to make sure that your installation, your upgrades, everything works and works well with everything else. And this isn't just the database, because the database itself can be very happy. A database can run by itself, and it can store information and have no problem with that whatsoever. But you have to take into consideration the applications, front end, the third-party vendor software, networking. Like, do your network connections, are there firewall exceptions that allow access to your database? Because if any of these do not align appropriately, you might have a bad time. You are going to run into issues. So you got to figure out where your problems come from and try to resolve them in a quick fashion if you can. Now, as far as multiple instances and subsystems, I kind of talked about this with having a Macon State College system, a Middle Georgia College system, having a Banner production system that we currently have for Middle Georgia State. And all of these take up space, and they all share resources and all. And then we have a test environment that's on another server. We have multiple servers concerning Banner, and all of these kind of take away from the resource pool. You got to figure out of all of these databases, which one should be allocated the most resources. The production system. How much do I allocate to the other systems to make sure that they run appropriately, but don't steal away from the main system. And you got, again, as I kind of mentioned before, you have to make sure that they all run with the appropriate interfaces, applications, third parties, outside sources, firewalls, just the whole lot. You got to figure out how these work and test them, make sure that they function, and we're moving on. Okay, as far as upgrading is concerned, there are a number of benefits to this, where you may get new features and new tools. Going back to the tried and true Oracle that I'm familiar with, I have, in my 5 years of working as a database administrator, have dealt with 3 separate Oracle versions just while I've been here. I've dealt with Oracle 10 in its declining stages as we were moving on to Oracle 11, which we're on now. And I'm dealing with Oracle 12 as a current project that we are moving to in the future. Now, one of the new, over time, we've kind of developed different initialization parameters that make things a lot easier to maintain. Say, for example, in Oracle 10, you have a shared space and a private space as far as allocating memory and resources, and you have to define each little parameter to make sure that everything works and syncs up. Well, 11 made this a lot simpler. Instead of saying, okay, here's the resources here, you know, and trying to find numerical values for each of the parameters, they consolidated them to a certain degree and created a memory target, which makes it really convenient. Well, as far as 12 is concerned, they've actually stepped it up a notch. And let's take our databases for an instance and say with 12, they've decided that you can like step back a little bit and say, okay, I want a certain percentage of resources going to this database, a certain to this database, and this database from one shared source, which is, we're not licensed for that yet, but that might be an eventuality. And that would be really convenient because instead of having to go to each individual database and allocating resources and micromanaging them, I can step back, look at everything as a whole and say, I want 80% of the resources going here, 20% going here, 20% going here. Or, oh yeah, 120%. That's what we want. We want our machines running at 120%. But you get what I mean. It could be 70, 10, 10, and the system itself may need to reserve 10%. Something along that line. Okay, as far as compatibility, I mentioned how we have the ticketing system, we have Nelnet, we have StarRes, the reservation system for dorms and housing and having residential students. Well, you need to if you upgrade your software, what is it going to do to these third parties? Oh, that's not a benefit. That's a risk. Well, that's the next slide. But as far as compatibility, you may be more compatible with certain software, and it may perform better as we see higher performance. You may have better support because you may be on the tail end of the life cycle for a particular version, or you may be several versions out of whack, which I've had software that I've been like 10 versions behind, and it finally cops out on me because I'm trying to upgrade. And so I have to approach the software provider and get that to work with our systems so that we can continue on and doing work. As far as cost benefits, this seems kind of counterintuitive because, hey, you're going to have to spend more money to shell out for new software. And we'll get to that. That's part of the risk. But as far as costs are concerned, they may have new features that make your processes run faster, and thus you may process more customers, or you may save time and effort and headache and all in your day-to-day processes. And these are unseen costs. Sometimes they're costs that you might not be able to go to a board meeting and show a pie chart and be like, hey, we saved this much money on it, but you may be saving costs behind the scenes. Now, as far as upgrading is concerned, you may be cleaning house. And what I mean by cleaning house, let's take, for instance, when I worked for Middle Georgia College, and we decided to go into consolidation, and I was working with Macon State. There were, I mean, both institutions had been operating for several years, and we began talks of moving to new servers and new systems. Well, that allows us to look at, okay, what are components that we don't use anymore? What are programs, software, files, folders, you name it, that we don't use anymore? What are things that have no benefit to us anymore? And it may have been kind of shelved in some directory somewhere, forgotten and not thought about in years. But in this case, having upgrades allows you to kind of be introspective, be able to look at your systems and be like, okay, we don't need to spend 5 gigs on this directory because these files are no longer pertinent. Or referring to a database perspective, there may be components in a database that are no longer viable. I know that there were some performance tools as I've upgraded that basically just go by the wayside, and there are schemas and logical partitions within a database that they no longer need to exist. That means you get to free up space. That's free space that you get just by upgrading and cleaning house and taking out the trash, spring cleaning. Now, as far as risk, you risk disrupting the company. If you have to take down a database to upgrade it, whether it's a point release or you're upgrading to the latest and greatest software, that means some downtime. That means that time that companies may be needing to work, departments may be trying to put in overtime and hours into, they can't work during those hours. Now, as far as a college is concerned, when it comes to weekends, that's less interruptive. But when you are talking about a company where a database should be available 24/7 and accessible, that can lead to hiccups and disruptions. And as we kind of talked about before, trying to garner support from the departments as far as testing for upgrades, that's a disruption on them because that takes them away from their normal business concerns. That means they're not getting their work done, and that does not make a happy end user. As far as costs, I kind of covered this on the last slide. You're going to have to shell out money in order to get the bigger, fancier, shinier tool. Performance and resources. Just because it's bigger doesn't necessarily mean that it's better. As far as performance is concerned, you may need to allocate more hardware, more power to support your new database software. That might be something that you may not, as a company, be able to afford. You need to figure out your strategy on that. Stuff breaks. A story about this concerning consolidation and trying to move away from unsupported systems. We have a number of local programs that Macon State has created over the years that we needed to migrate from a Unix to a Linux system. Well, in this regard, there were a number of programs that had a particular syntax that just refused to run from a Unix to Linux environment. And you would think that Unix and Linux are fairly similar, right? They should just, like anything that Unix can do, Linux can do better, right? No, that's not exactly how it works. They're two completely different operating systems. They speak in different ways. And odds are you need to test to make sure you know what's going to break. If anything breaks. But odds are when you're moving stuff between operating systems, new software, stuff is going to just break on you, and you're going to have to investigate why. And in the case of the C programs that broke when we migrated, that was manpower that we had to dedicate to updating the programs to function appropriately on the new server. And for those programs that we didn't touch, we had to figure out what programs were even pertinent anymore, going back to the whole cleaning house thing, and what programs we needed to prioritize on, because some programs are used in higher capacity than others. As far as support is concerned, you risk having to go to a software that may be brand spanking new and nobody knows anything about it yet. That's the problem with having shiny new toys. People may not be familiar with the problems that you're running into. So you have to work with the vendor. They may have to spend more time and effort causing more of a disruption on your end users until they find either a workaround or a way to actually deal with the problem. If there is that time, you may actually have to have a patch and wait for that kind of support before some of your processes function appropriately. Additional considerations. This kind of goes hand in hand with the whole third-party software. I kind of really discussed this with the integration and the compatibility with vendors, outside sources, as far as stored procedures and functions within your database. Software DBMSs have gotten more complex over the years in the sense that they store more objects and actually programming nowadays that you have to take into consideration. Years ago, when it came to a DBMS system, it was a database was just happy storing information. It had one job and it did it really well. But as far as time has graced our technology and advanced us as a business culture, we have adapted ways of integrating procedures, functions, triggers, and sequences and various programming objects within the database. And so you have to keep track of those. They're not necessarily a tangible thing anymore. They might be a part of the database, and you have to keep track. It's like, do they break? Do they function appropriately? You may have to follow the bouncing ball as procedures and functions reference one another, and you have to jump in between those. Trust me when I say, when you get into a production system, an enterprise level system, it can be pretty tough trying to follow the bouncing ball between procedures and functions that you have within your database. Now, that could be the same as your C programs, your COBOL, your Java, so on and so forth, but it can be even more complicated because you don't have files readily available per se. It's stored within the databases, and you have to take those into consideration. Okay, reputation and support when it comes to this. We kind of talked about it with support for your DBMS, but you also have to take into consideration who you're going to basically work with. What companies are you going to basically be shaking hands with, making deals with, trying to figure out, are they going to support their systems? Are they reliable? Can you go to them and talk to them on a reasonable level and get the feedback that you need to basically run your systems with as little interruption, as little problem as possible? You also have to take into consideration your organization style. I kind of misspoke earlier when I said type 1, but for type A, these are a type A organization may be early adopters, those that are very tech driven, that need to stay ahead of the curve and ahead of other companies in the technology advancement. There are type B companies that they're happy enough to wait till the kinks and the bugs are worked out before they grab the latest software. And there are type C organizations that they don't want to spend money. They just, it's like, money is that 4-letter word, and I realize it is 5 letters, but that's a 4-letter word for businesses sometimes, and they might not want to risk going to a new system until, quite frankly, the technology curve has gotten to the point where it's no longer viable for them to stay on the current system. I feel that this chapter is kind of redundant. We talked about how the DBA staff skill, you have to take into consideration they may need additional training, the platform support, what operating system that you're on, what kind of hardware you're on. Are your servers virtual? Are they physical? What kind of platforms are you running? What kind of supporting software do you have? Third parties. Again, fallback planning. This is a little bit more. Let's say you decide that you go to a new version and you test it and everything seemed to work fine, but you get to the new system and holy smokes, the house is burning down. You've gotten to the point where your software doesn't do what you need to do. You are at a critical level. You need to back that thing up. You need to go to your old system until you put out that fire and figure out what went wrong. You need to have some sort of contingency plan, and say it like moving to a new version of Oracle or moving to a different database doesn't work like you think it's going to work. You need to be able to backpedal. You don't need to go ahead and blow up the system. It's like, oh, I've tested this. I've made sure that it absolutely works. We don't need to use the old system anymore. We can blow it up. You blow that old system up, and you're on your new system, and it's a sinking ship. You're in trouble. And as far as migration is concerned, moving between different operating systems, moving between different servers, unlike Microsoft, where you have Windows that you can upgrade, on the same system. I have a lot of experience with Linux at this point because I've had to jump between Linux and Unix and Linux 5 and Linux 6. And there's no clear-cut way to just go ahead and say, take a Red Hat 5 system and just apply upgrades to it to make it Red Hat 6. That's not how it works. You have to have a different machine, and you have to migrate your systems to it, again, a lot of hassle, a lot of headache, and you have to take into consideration testing and making sure the stars align so that everything works, whether it's interdepartmental or outside of the company. Standards, naming conventions. You really want to kind of get into a descriptive naming convention system where everybody kind of uses the same language. Trust me when I say when it came to consolidation and taking basically two institutions, two businesses, two schools that may have they may both have banner systems, they both may have students, but good heavens, people will talk differently depending on what they're familiar with. So having a set naming convention system so that everybody's on board, everybody speaks the same language and doesn't feel left out, doesn't get confused by terminology that they're unfamiliar with or used in a different way. It all needs to be consistent. Roles and responsibilities. You need to be able to understand, okay, if there's a fire going on in your system, who needs to address this? Who do you go to? Who are the people that you need to call? Communication standards. For us in particular, as far as Banner is concerned, with staff and faculty, we require staff and faculty to have tickets in order to work problems. This is a standard that we set up after auditors came by and said, hey, we really need you to track the amount of work you do and changes to permissions and all. And we were tracking some of that, but we weren't necessarily tracking that to the level that they figured it needed to be. And as far as communication is concerned, sometimes people want to email you, some people want to call you, some people want to use a ticketing system. You need to really kind of set the standard, set the bar to say, hey, we need to really have one-stop shop for communication, because if you're having to chase 3 or 4 or 5 different rabbits, different communication avenues, then you're going to have a bad time. You're going to have to figure out what is going on, and you may overlook emails if that's not your primary form of communication. Positional standards, that's roles and responsibilities. Security standards. As far as passwords are concerned, we had to deal with, okay, how long does a password need to be? What kind of characters does it need to consist of? What are the steps in order to reactivate your account? Should it have been locked or you got the password incorrect? Do you have something online that you can have users go to, or do they need to call a representative of tech support and get them to walk through it? All kind of depends on the level of security that you're in. Operational support, being able to figure out who actually can communicate and walk you through step by step what you need to do in certain scenarios. Say, for example, like I said earlier, I don't particularly deal with the front end as much. So when it comes to a financial aid user, it is imperative that if it's a financial aid process, they really need to do training in the department to figure out what their job is supposed to do. If they come to me and say, hey, I'm trying to run such and such processes against FISAP or whatever acronym they're using nowadays, I'm not going to have a clue. I'm not the one to come to. I may try to help. I may try to look up stuff, but if it's something that's not within my knowledge or scope to be able to handle, they need to be able to communicate effectively who they need to talk to. And education. As far as a good company is concerned, they need to be able to support continuing education for their faculty and staff, especially for IT, in the sense as technology grows and advances. As I kind of pointed out, I've already been through 3 different Oracle versions in my stay at Middle Georgia State, and that's been 5 years. That's a lot of advancement. You need to have some sort of training opportunity to be able to send uh, your administration to be able to catch up on what changes are being made, what kind of tools there are available to them, so on and so forth. Okay, chapter 5. As I said, we kind of, for the most part, chapter 5 is a little bit, I don't want to say unnecessary, because there's some good information in it, but a lot of it is content that may be pertinent to your job. It may not be pertinent to your job. There's a lot of communication when it comes to uh, application programming languages, whether you're dealing with Ruby on Rails or Java or XML, so on and so forth. I deal with a little bit of XML. I deal with C. I deal with COBOL in a limited capacity. I have dealt with Java. But as far as you're concerned, whether you're going to be in another college or institution like I'm in, or you may be working for big business Fortune 500 company, what you use and what you deal with is going to be considerably different. Some consider that COBOL is a dinosaur, and there's a little bit of a mention in here of COBOL, but some companies have just stayed away from it and try to avoid it like the plague. Some companies, like ours, we have hundreds of COBOL programs. If you have had any financial aid whatsoever in your stay at Middle Georgia State, odds are you've had COBOL programs run against your records. I'm just saying there are a lot of COBOL programs. Some people are trying to convert them. Some people are very much happy with COBOL, and it runs and it works, and everybody's happy. So, I mean, there's mention of object-oriented programming in SQL. All of this is going to be fairly redundant for those that have taken programming classes, that are familiar with it, that have even so much as glimpsed at it. So I don't really want to waste your time by requiring you to know what all of these programs are, because by the time you become database administrators, some of you, as we kind of discussed in last week's discussion, some positions it may take 3, 5, 7, 10 years in a database related field or programming or what have you before you even are allowed to be a database administrator. So some of these um, application elements are they're not going to be pertinent to you anymore. Some of them may be used, but I don't want to waste your time on them. If you want to review them on your own, you are more than welcome. But I am starting, as far as chapter 5 is concerned, on page 205, as long as our textbook is online, or the defining transactions section. Now, a transaction is an atomic unit of work with respect to recovery and consistency. Basically, you run a program or a set of programs. A transaction is any sort of, let's say somebody needs to enter a student in as a new student. just by changing one set of records, that doesn't necessarily mean that it's the entirety of a transaction. It may be more complex. It may be updating multiple database, tables and all at once or in succession. It may be a larger multi-step process, but a transaction can vary. Whether it's one select statement, or it could be a select and insert and update and another select to show you that stuff is done. Transactions kind of vary. When it comes to transactions, there is, I may very well butcher this word, atomicity, where if you run a transaction, it's all or nothing. It either succeeds or it fails. If it starts to run, it's going to run all the way through, or it's just not going to work at all. Or if in the middle of processing, it'll roll back your transaction to say, no, it's done. Consistency. As I kind of pointed out with transactions, they can be multi-step. So you want to be able to be correct at all stages within a transaction and be consistent. Say, for example, you're going down a list of payments and you process the first 5 payments. And let's say that you are approached with a problem that basically is more imperative to deal with than this one customer's payment transactions. It may be a phone call. It may be a building is on fire. I don't know. It interrupts you. But in dealing with the first 5 payments, after dealing with all of them, all of the first 5 at least, you're correct at all points. You're consistent. Each one that you've gone down the checklist, as long as you finished dealing with each one of those, it's fine. And if you had to stop in the middle of your transaction, it's fine because it's still correct. It's still processed up to the 5th level instead of the 10th level. Isolation. Basically, transactions need to be able to be separate from one another. Let's say that admissions, just to kind of throw a different department under the microscope rather than financial aid, as I've kind of just brought them up over and over again. Let's say admissions is running a process, and let's say I'm running a query. Let's throw me under the bus here. And we're running completely different transactions against the system. They need to be able to work at the same time without interfering with one another. That's the beauty of isolation. Durability. Having a database management system that's reliable is very pertinent, and sometimes there's power outages. If anybody paid attention to Banner or Swords or any of those related systems over the New Year's holiday, you may have seen that it was down quite a few times. And that was not necessarily because of the Banner system, so much as there were basically the stars aligned during that week to cause a number of issues to occur. Monday, we had a power outage. It was supposed to be a planned power outage in like the Jones building or PSC or something like that, but somehow it was tied to the library where some of our servers are housed, and that just caused the whole debacle of systems to just shut down unplanned, and then we had to start them back up. Well, again, stars aligned. During the outage, we had processes that were running that basically just kind of went haywire and used way too much CPU that caused some hectic situations to occur, and having to shut down the system again and boot, and we did that a couple times. We had fun over the holidays. But as far as this is concerned, uh, the system was durable enough that even though we had this outage, even though we had this failure, even though we had the CPU running at max capacity and just kind of blowing up in our faces, I was able to, at the end of all of it, turn on the system and it ran without issue. That's the kind of durability you want, and it was consistent. There was no data file corruption or any of that sort of stuff that I was afraid of. It was durable. It held out during all of that. At the transaction level, let's say during business hours, this kind of happens. What happens to the transactions that are like halfway through? Some of them may need to be revisited by the department that was running them to assess some sort of damage. If during the process, like some of the consistency of the data is in question, it for Oracle systems, it may not basically save it until the transaction is 100% complete. Whatever the case may be, you need to have a robust system that is consistent, that it is durable enough should basically meteors just come down and crash it or whatever. Not that extreme per se, but you need to be able to handle transactions in the event that there's unforeseen circumstances where it goes down. Unit of work. This kind of goes hand in hand with the transactions in the sense that, let's say I enter information and I get some sort of feedback from the system to say, okay, hey, I need you to clarify, your circumstances, like, are you wearing the blue tie today or are you wearing the red tie today? Or whatever the case may be, to get through the entire transaction. That's the whole unit of work, and that's probably a better way of me explaining it than the transaction altogether. The other part of chapter 5 that I really kind of want to focus on, and it may have you all do in a lab, I may either show you in a video how this works, or I may, depending on time constraints and everything else, I may actually have you experience this and do this on your own. Because I have tested this. This actually does work in MySQL to be able to experiment by yourself and cause locking situations. Locking situations, this is how you make sure that the data integrity is intact. It works very similar to a library system. In a sense, let's say I'm going to pull a name out of the hat. Let's say Devante goes and wants to check out a book, and he does. But let's say Jedediah tries to come in and wants the same book, but there's only one copy of the book, and it's checked out. Well, he's going to have to wait. That's where the locking comes in. This can happen on a table level. It can happen on a row level. It all really kind of depends on what needs to be reserved by a certain user as they're updating data, inserting data, deleting data, so on and so forth. Now, as far as locking is concerned, it really all depends upon how your application handles locking. I've seen scenarios where, or explanations. I've seen a few different type of locking scenarios where one application may allow multiple users to interact with the system at the same time, being able to read it but and one of them may be able to update it, but the other person may still be looking at old data. There are some times where you'll have an application that will prompt a user to say, "Hey, somebody has updated the data," and since somebody has performed a transaction, and do you want to see the updated data? Okay, as far as uncommitted reads are concerned, it allows users to basically go in and see what the data is at the time, even if somebody is in the middle of a transaction and they have not saved the data yet. Say user 2 comes in and sees user 1's data, it may not be accurate because they're in the middle of working on it and they haven't saved yet because they're still verifying it. This can compromise data integrity. As far as a committed read is concerned, it only allows you to see data that has been saved. Now, this is a little bit improved over the uncommitted read that may not even have accurate data at all, but at the same time, it may not be 100% accurate, as somebody may be updating it at the point that you're looking at it, but they haven't saved it yet. A repeatable read is being able to see the data that it may be accessed over and over and over again, and you're going to get the same consistent data every time, and you're not going to have any sort of confusion about it. Like, no matter from point A to point B, you're going to get the same data. It's always accurate. Serializable. This one's kind of interesting because I know that Banner is actually trying to strive towards this, but in essence, it's adding kind of like a new field value to tables and records and all to say, hey, the numerical transaction for this is 1 or 2 or 3 or whatever, and you go in and you start. Let's say one user is dealing with the data, the second user comes in. First user decides that they're going to update the data. Second user decides that he or she is going to update the data, but the database takes a look at the serial number that user number 2 is looking at and says, hey, the data has been updated since you've actually accessed this by another user. You may want to refresh the data and look at it before you update it. That's and it just has like a numerical 1-up auto incremented value to be able to say, oh, well, stuff has happened since I've actually dealt with it. All right, now moving on, we're gonna finalize and get ourselves to module 2 and dealing with database objects. I am going to express my apology in advance. I was looking at various different SQL tutorials before I actually picked one out for you all to kind of pursue. And when I told you all last week that you were to read all sections, I was thinking of a different SQL tutorial that was not all inclusive and had the constraints, the views, and everything else included. So when I said to read all sections last week, I did not take into consideration that it had these extra components with it, so I apologize if I made you read more than you really were prepared for last week. So, but if you're a positive kind of person, you can look at this in the perspective that, hey, I've already read this. That means I don't have to read this again. Or if you're in the camp that, hey, I didn't bother reading this because it wasn't even detailed in the module, that we were going to go over this material, congratulations, you have another week. All right, so the task list, watch the video lecture. You're doing it. Congratulations. Participate in week 3 discussion. This one is a little bit different from the last week in regard that I'm not going to require you to respond to any of your classmates. Participation is encouraged, but the discussion for the week is very one-dimensional as it is concerning schemas and basically defining them. I don't feel that people are going to vary too much. There's a little leeway because some people may look at database schemas from the perspective of Oracle. Some may look from the perspective of MySQL. Some may look from the perspective of SQL Server. And quite frankly, they all, at the base level, have the same definition, but all handle them in completely different ways. So whatever route that you're going to go between DBMSs, please be thorough in your investigations with them. But as far as participation is concerned, I'm not actually going to be grading that as long as you make your post. And your post doesn't need to be by Thursday like last week's because, again, you're not responding to other people unless you're happy to do so. Anyway, as far as the SQL in practice is concerned, we're going to be reviewing sequences. In MySQL, it is simply auto increment. Sequences are handled vastly different depending on which DBMS you're working in. In the case of MySQL, you have a very limited capacity with the auto increment. It's just going to go up by values of 1 and steps by 1. Oracle and SQL Server will actually allow you to dictate where your starting value is, whether your values go up 1 by 1 or 2 by 2 or go in a negative direction. There's vastly different ways to handle sequences. It's very, very simple when it comes to MySQL. As far as creating the auto increment fields, or rather in this case, updating your primary keys to be auto increment, you may need to remove the foreign keys by altering the table beforehand, and then going back after you've updated the fields and then restoring your foreign keys. You're to create a serial number column on the products table and make it a unique field. Unique fields are kind of primary keys in a sense, but they're, to be more accurate, they're alternate keys. They're values that cannot be repeated. They could be used as key values in a sense, but they're not atomic enough. Or there may be other various reasons to make them unique, but they can't serve as a primary key. Just to kind of give an example for this, for the purposes of learning and giving you the inside look into your own experiences as a student at Middle Georgia State University. Some of you may be aware of this and some of you may not, but you have a 983 number. It will probably appear on your ID card if you have one. But your 983 number is your unique Middle Georgia State ID number. However, if you attended Macon State or Middle Georgia College, you should have a Macon State or Middle Georgia College ID number. Since you have multiple ID numbers, but you're one person, what does that mean for your ID? Well, it still has to be unique, but that's not necessarily the primary key that ties all of the IDs and all of your identifying features together. So that's where the unique constraint comes in. And I kind of demonstrate this with the whole serial number thing. You may have a serial number that is outside of a company's scope to be able to handle, hey, I didn't create the serial numbers, or our business didn't create the serial numbers, but we need to have our own designation for it. Check constraints. This is going to give me nightmares. I tried so hard to get these check constraints to work, and I found out that, oh my gosh, check constraints do not work in MySQL. You can create them all day long. They do absolutely jack all. So as far as I'm concerned, you don't actually have to test them. I would recommend testing them insofar as the syntax actually runs, that you're able to create one. But if you try to even test it to make sure, hey, I want to make sure quantity values do not go lower than 0, it does absolutely nothing. I have even tested this with triggers. I've done this with direct SQL statements. It just doesn't work. It's even said in MySQL documentation that it doesn't function. I was going to actually have you guys query the database to show, hey, this was created. I couldn't even do that. But for the sake of learning syntax, just give me the code. Just give me the code. For testing default constraints, this is a little oddball one that I kind of threw in. For the customers table, concerning the city field, we're just going to default it to Macon. Go ahead and create the statement to alter the table, test it out, verify, give me the screenshots that I am so greedy and hungry over, and tie the bow on the knot and be done with it. Okay. On the orders table, I want you to add a date time field by the name of order date, and basically test it out by inserting a new order into it with the now function. The now function is exactly as you would think it would be. It puts in the date and the time that you actually ran the transaction. And this can vary wildly between MySQL, Oracle, and all the other ones. I know it's sysdate for Oracle, and it's now for now. Verify it. Give me those yummy screenshots. And lastly, I want you to revisit number 5, that the query that has given some of you all nightmares, and make a view of it. Not really that complicated. Should be just create view as blah 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 and tack on the query, and it should be as simple as that. And you should pull up the same information that you pulled up last time. As far as the work for last week, I am doing this lecture at almost 8 o'clock on Sunday. Waited till last minute. And as far as I'm concerned, you don't. I may make a video to kind of review what occurred in the transaction last week, but I allow up to 2 days of late time at 10% deduction per day. So I don't want to actually spoil the work yet, or what have you. As last week, please create a lab assignment document, name it with the naming conventions, put the required content in there, and label it. And as always, please provide feedback so that I can help tailor these modules, this whole class to you guys, so that I can improve as a professor, so that I can give you guys a better experience, and make this class fun, worthwhile, and engaging for you all to learn. I know that some of this can be really daunting for you all, as I've kind of seen the experience over time, but I promise you, if you put in the work, make sure to read carefully, follow instructions. You're gonna be fine. I'm not heartless. I'm not gonna give you zero credit if you at least tried. Um, but I do need to show a certain level of effort on your part. Um, if you need help and you need to email me, feel free to email me. Make sure you follow the syllabus guide and put ITEC 4242 and your name in the subject line. I have been a little bit lenient on that in the last couple of weeks and have answered messages that have not followed this guideline, being guilted into it by my wife and by my own conscience. But I stress with all the fiber of my being, please put that in the subject line or I will delete without reading. I am not going to be lenient on the weeks to come. It has been 2 weeks already. Make sure you follow the guidelines because I want to make sure that I get the emails, that I read the emails, but it doesn't interfere with my 9 to 5, so to speak. Because I get enough emails as a database administrator that I need to deal with on a daily basis, and your emails can be lost. As far as I did get a little bit of concern from a few of the classmates as far as questions and concerns about actually using MySQL and the editor as far as Workbench and everything else. I'm a little bit unclear as to what you're unclear about. I mean, I kind of really need a little bit more feedback from you all as far as where the confusion is. If it's a confusion about the language that I use in a document, you know, like highlight it, copy it, whatever, send it to me in an email, take screenshots of any errors that you have. But as far as emails that say, hey, I just don't understand this, please help me, I can't really deal with that. Not that I my heart doesn't go out to you. I really want you all to succeed. I want you to be able to learn and grow in the environment that I have created for you all. But I am very much like a computer. If you do not give me any input, I can't give you output. I hope you all have a good week and good luck on your assignments. Again, talk to me, email me, go to the discussion boards to the Q&A, or see me during my office hours or any of the other times that I'm on Skype. If I'm on, feel free to message me and so that I can help you help yourself. Peace out.